should be going well. So thanks very much. This is the slides, and I won't say much more about what they are than what's been said, other than it's based on some of the ideas and some of the work that I've been developing over the last 5-10 years, and that it's building also on some of the projects that I'm currently working. So before I continue, if you're interested in following the talk, the slides are online as well. So you can either scan the QR code with your smartphone or go on the link, and that should take you to the slides that I'm using right now. And throughout the talk, there are many links, and they will all be clickable there. So if you have the slides, you can follow more easily. And I should say that the common thread actually of this talk is a book that we have in the works, and I'll use the book as the main thread because I think it's a great example of some of the core ideas of what we understand to be geographic data science, but also some of the ways and the methods that we consider geographic data science and how to get them out to people and spread the word. So the short news is that we have a book coming that it's almost there. It's coming soon, but as of now, you can already see the book as it's being developed. You can go to the website geographicdata.science, and all of the project is going there. The book as it's today can be accessed online, and it's also interactive, and I'll talk a little bit more about that later. But if you want to click on the binder button, that will take you to an interactive instance online that will allow you not only to see the contents of the book, but to run them. And if you find any problems, I'll talk about that a bit more later too, but the book is an open project, so you can report them, and hopefully as soon as we can fix them, and you can also contribute to make the project better. So who is behind the book? This is by no means only my own work. This is collaborative work, and it's a team sport like all of geographic data science. It's together with Professor Serge Ray at the University of California, Riverside, and Dr. Levi Wolf at the University of Bristol in England. And we've been working on this for at least for the last 2 years, if not more in spirit, but definitely for the last 2 years. We're really excited to have it out, and we really can't wait to see what all of you make of it. So that's the announcement, and the reason why I started to talk through the announcement of the book is because I think it exemplifies really well many areas that I want to talk about today about data science, GI science, and geographic data science as an intersection. So what I'm going to do in the remainder of the talk is start with why we decided to write a book about geographic data science. That's not a topic that you would find many books today, and it's not a topic that it's not a term that you would necessarily see featured in many places yet, we think. So I'll talk a little bit about why we think it's a good idea. Then I'll use the book as a platform to talk about some of the core ideas of what we understand geographic data science to be, and what are the main core elements and building blocks, but also the main approach to talking about them. As you'll see later, a lot of geographic data science is not necessarily new, is aspects, ideas, and concepts that existed before in different fields. And if anything, what is new about geographic data science is bringing them together and giving them a new life, if you wish. So we'll talk about what are those different elements that we consider, and this is by no means a finished enterprise, so it's very much up for debate and refinement, but I'll talk at least about where we are today. And then the third part of the talk will be what I call how we're doing this, or how we think this should be done. And this will be elements about infrastructure and how we're building the book physically. What is the digital infrastructure that we're using? Because I think it says a lot of things about writing a book in the 21st century, but also doing data science and geographic data science. And then I'll hopefully close with a few comments about how we can build a broader community and how we can make these easier for more people to join, how we can lower barriers. All right, but first first things, and let's start with the principles, with the idea of why we decided to write a book like these. And there's many ways of explaining these. The best one that I've come across is with a few emojis, as everyone seems to explain things these days in the 21st century. And to us, everything goes back to the data revolution that has been undergoing the world for the last 2 decades. It varies on how who you talk to or how you consider this revolution to be, but roughly in the last 2 decades, we can probably all agree that there's been a notable increase in the amount of data that's being generated. A lot of that started originally in tech companies in Silicon Valley, when they started realizing that the server logs that they were saving for operational purposes actually had a lot of value, and that knowing where people clicked on their website and when they clicked and what they clicked after they had clicked on another place, they realized that it wasn't only good for keeping their servers running, but it was actually good for their business. And that if they could make more out of those server logs, they could make more money, essentially. And what that essentially translated over the years, and you see these, you could argue these started with the internet companies in the late 90s, but mostly early 2000s. And definitely as you move into today, companies like Microsoft or Amazon or Facebook or Google, they're all starting to become what they are today in the early 2000s. Now, I said that they realized that their server logs were very useful, but they also realized that it wasn't necessarily the most useful thing in their current state. And that in fact, there was a lot of art in the beginning, and then we would call it a science, to transform those logs into actionable insights or actionable information that they could use to make better decisions, and ultimately, in their case, to make more money. And over time, what this became was what we've come to call data science, which was a blend of a little bit of statistics, a little bit of computer science, a little bit of machine learning that then later became what we call artificial intelligence, a little bit of software engineering, a little bit of databases and what was called data mining, that today is probably more referred to as data science, a little bit of visualization, and a little bit of storytelling, or what it's also referred to sometimes as domain expertise. So the ability to communicate complex ideas in intuitive ways, but also the expertise that comes from knowing what your data is about. So in the original case, this was about the user base that was accessing these platforms, these web platforms. And we repackaged all of these. Many of these things existed, and since then there's been many of things that have been invented explicitly under the umbrella of data science and artificial intelligence. And if you think of the revolution that computer vision has gone on the last 10 years with advances like deep learning, this is all new stuff. This, of course, it doesn't come out of nowhere, and a lot of those core ideas existed, but a lot of that has been new developments. And I think that applies not only to the area of computer vision, it applies to a lot of the areas that we would call today data science. They started with ideas and with principles that had been around for a long time, but then once the area becomes more relevant, there's a lot of innovation and there's a lot of new development of methods that comes and builds on that. And before I continue, I should also say that what I talked about the data revolution as if it had only happened in Silicon Valley, and that's because I think that's where it became more prominent and where it started, at least in spirit, even though you could argue there was another data revolution going on in finance with high frequency trading. There was another revolution going on in Earth observation, which is much closer to the area of this symposium, where we started collecting a lot more data than we had been able to, and we started realizing that unless we transformed them in some intelligent ways, we weren't going to make the most of them. So even though in spirit the data revolution originates in Silicon Valley, this very much spreads to all areas of society, and today we're basically walking data generators. We carry supercomputers that we call smartphones that are constantly tracking many of our activities, and not only our own computers, but other deployed computers in the form of sensors, in the form of satellites, in the form of trackers of different kinds, are constantly and passively in many ways, in many cases, collecting data. And as a response to this large amount of collection, but also generation of data, data science has emerged as the field that kind of blends together different disciplines to make the most of large troves of data. And all of these, at least in the beginning, definitely when it started in Silicon Valley, there was the sense that all of these data sets were happening in a vacuum, that because there were server logs, there was no location, there was no geography, right? But actually, when you think about it, all of these data are inherently spatial, or most of these data are inherently spatial. They either have a very explicit record of location at the same time that they have a record of time in the form of a timestamp when a click happened. Usually they also have a record of when that click happened, and that might be explicit in the form of coordinates for latitude and longitude, or it might be implicit, it might be an IP address. But one way or another, the truth is that many of these data sets have actually a very explicit spatial dimension in their generation. And now, even more important, the idea that space is crucial not only to the generation of the data, but that it's crucial also, or is very important to the kinds of questions that people are trying to answer with what we would now call data science. This was always the case, but it's definitely even more the case today with many of the data sets that I've talked about a second ago. It's the case, obviously, with the case of Earth observation, where it's about mapping the Earth in high resolution, both spatially and temporally. But it's also the case trying to answer questions about, for example, mobility, when we're using GPS traces from smartphones, and we want to see how people are moving, extract patterns so we can, for example, plan better transport systems, or we can support populations that are unable to access existing transport systems. So the notion that data happen in the ether, that they're generating a vacuum that doesn't know of space and that doesn't care about distance, it's been at best a simplification and at worst an omission. And that's trickled down to the development of data science. A lot of the methods that you would see today branded as data science are non-spatial or aspatial, in the sense that space is not properly recognized. And this doesn't mean that these methods are wrong. What we think it means is that these methods don't make the most of the data. They could make more, they could extract more value, they could extract more information. So as a result, for all of these, what we've actually been trying to say, definitely from Liverpool, but also from other places, is that data science is not really data science, that it should be called geographic data science, or as our US and American friends call them, spatial data science, that there is an inherent role in space and geography that if you ignore it, you're leaving value on the table. It doesn't mean you're doing things wrong. It means for us that you're not making as much as you could make out of your data. And this goes both for industry. You're not making as much money. You could make more explicit, more accurate predictions. You could make cheaper predictions. But also from the point of view of science and research, you're not extracting as much insight and you're not learning as much about your data as you could if you were recognizing the spatial or geographic dimension. So as a result for that, we've been arguing for a while now that there should be something that it doesn't replace other things, but it complements existing developments that we decided to call geographic data science. And other people have been calling spatial data science or geospatial data science, and there's other terms. And I think they're all fine because they try to capture the same idea. What you're seeing there, and you can click if you want there to take you to the paper, is a publication that my colleague, Professor Alex Singleton at Liverpool, and myself officially published last year, or actually came out in print this year, but it had been in the works since 2015. And these are some of the core ideas that we've been trying to developed, definitely from Liverpool and together with a broader community, to bring together the fields of data science, that what was emerging and what was becoming known as data science, with geography, and more specifically geographic information science or geographic information systems. So just to give a bit of a preview, and in particularly as it's relevant for this talk, we envision geographic data science as a space for interaction, particularly between GI science and data science. It's a place for cross-pollination and where the two fields come together. And the idea is foster innovation, or at the very least, avoid reinventing the wheel. What we realize is that on the one hand, there was a lot of, because data science was dealing essentially with spatial data, we realized that a lot of people were having to work with data that had a spatial dimension, but weren't necessarily trained or weren't necessarily aware that there was a lot of work being done on understanding and working with spatial data. So but people had to come up with answers and had to give answers. So what they started doing was coming up with shortcuts that would get them to answers that more or less were what they wanted, but that, for a traditional GI scientist would not be necessarily clever or sophisticated. There was a lot of reinvention of the wheel. There was a lot of trying to patch things up to make them work. And there was a lot of basically reinventing GIS systems inside the world of data science. So we think a lot of what geographic data science is about turbocharging data science with everything that we know about working with spatial data and dealing with space when it comes to data analysis. And this is, for us, the contribution that geography and GI science should make to data science. But at the same time, we also recognize that GI science has been around at the very, at least from the 80s, which is coming to 40 years now. And in many ways, it's pretty set in their ways, and it's been built around a set of core technologies that in many ways are becoming not obsolete, but at least dated, if not obsolete. And we think there's also a big role for data science to infuse traditional GI science with new technologies, things like the cloud, things like new programming systems that have programming languages that have emerged as the bread and butter of data science, things like R and Python that had been around when, in some cases, they were around when GIS was invented, but they weren't ready for being used and for being kind of embedded in GIS. And because of that, they kind of grew in different paths. And we think there's a lot of value in bringing those paths together today to make things more, to make things better. So this is the part about avoid reinventing the wheel. We also think there's a lot of value in fostering joint innovation. I was saying a couple of slides ago that if you think of how data science developed when it started, it was all things that already existed. A lot of what we would call machine learning, many of those methods had been developed a long time ago and they were already existing. They weren't new, but that was what was readily available. Now, if you look at how that evolved, a lot of those methods were refined and in many ways were superseded by newer methods. This is very clear in computer vision, where deep learning made a huge splash in the early 2010s, and that became neural networks became cool again. They became very, very powerful, and they've taken over many of what used to be a field that had very little to do with neural networks in 20 years at least. And a lot of those neural networks, they built on old ideas, but they're new methods, and they're methods that have been kind of updated and refined. And we think there's a lot of opportunity also for doing things like that in the geographic data science space. We think there's a lot of potential for combining notions or combining ways of thinking that come from data science and from machine learning and embedding them in traditional GIS systems. GI science actually hasn't had a lot of interaction historically with machine learning and with AI. And in fact, if you look at the early papers that set the field of GI science, the early 90s papers by Goodchild mostly, but also by others, in some of them, it very explicitly says that AI was kind of left on the side, at least for the time being, because you could read it in different ways. The way we interpret is that the field wasn't ready for being applied to GIS at the time. And we think there's a lot of opportunity in revisiting those views and merging or having both collaborating much more. And we also think that geographic data science should be a place where a larger and a broader and more diverse community can be grown, and that community should be developed around collaboration. And there's this idea that is not the sum of the GI science community and the data science communities, that it should be more than the sum of its parts, that it should be something that generates things that neither of the two communities could have developed on their own. So those are some of the core ideas that we're trying to advance with the idea of geographic data science. So I'm going to move forward a little bit in the interest of time, and then transition into the second part of the talk, what I'm calling what are the elements of geographic data science, or what are some of the core principles. And in some ways, I'm going to come back to the thread. Well, I should have said, actually, if you come to these, one of the areas that I'm backtracking for a second, one of the areas that we realized that was in need to grow this community and to foster innovation rather than reinvention of the wheel was to spread the word of this idea of geographic data science, but also to get more people on board on this notion. And that also meant upskilling people. So the idea of the book actually came from us realizing that there wasn't many materials that people could use to start learning what we would call geographic data science, that a lot of what was available 4 or 5 years ago was mostly patching up things that were scattered around the web, that didn't have a structure, that didn't have a common thread. And that was really the inspiration for how we decided to build the book. Now, once that we've decided to write this book, how do we structure, how do we approach it? And I decided that it was a good idea to start talking a little bit about what we think the book is, and then we'll talk a little bit about what the book is not. And I think between the two, you will hopefully get a sense of what we're trying to pitch here. So this is a figure that I've taken from our original book proposal that we sent to a bunch of publishers to try to convince them to let us publish the book with them. And it's a Venn diagram, very classic, nothing new here, where there's an element of data science, there's an element of GIS, and there's an element of Python. And when we looked at this 4 or 5 years ago now, we realized that of these 3 elements, you could pick any 2, and you would find at least one book that addressed some of those needs. There were a lot of books on data science and Python, because Python is the lingua franca for data science. There were some books on GIS in Python, and there's been a couple more since then, but this was already something that existed then. And there's also books that are starting to emerge around data science and GIS, but they weren't necessarily in Python. In particular, the Lovelace and colleagues book from a couple of years ago, and now Roger Bevan and Etzer Bebesma are also writing a book on spatial data science in R. But we felt there was a niche that we thought needed to be addressed at the intersection of these 3, that there wasn't something that covered data science and GIS and used Python to introduce those ideas. And I'll talk about later about why we think Python was an interesting choice, and it was one that needed to be filled. So this is really what we tried to do with the book, and it was, I think, a reflection of what we felt was needed at the time, and hopefully it's still, I think it's still needed. Now, this is what the book is not. It's not a GIS starter. It's not an introduction to GIS in Python. As I said in the previous slide, this we feel is a niche that is very well addressed. There's been a couple of long-standing books that have been running for at least 10 years, and there's more coming in the pipeline. There's a new book by Henrikki Tenkanen in Finland and colleagues. There's another book that O'Reilly has coming up as well. And it's a field that it's been around for longer. And because Esri adopted Python, Esri, the makers of ArcGIS, adopted Python as their scripting language, and QGIS later also adopted it too, we feel that there's enough material that we we don't need to make a contribution. And what the book is about is, of course, it uses GIS, but it's not a traditional introduction. You won't learn in the way that you would you won't learn about spatial data in the way that you would in a book about GIS. It's also not an introduction to programming. The book is entirely about well, uses programming throughout the entire book, from the very first chapter all the way to the last one, but it's not an introduction to how to program. It's a book that uses programming as a vehicle of communicating other concepts around data science and GIS. We cover the very, very basics that we think you need to understand the rest of the book, but it's not a programming starter. We don't start with for loops. We don't start with variables. We don't start with lists. We kind of introduce them as we need to, when we need to, for explaining another concept. So when we need to make several maps, we might use a for loop, and we might spend a little bit more time talking about it. But it's not I wouldn't recommend it as an introductory book to how to program in general, because it's very much programming as a tool, as a vehicle for communicating other ideas. And then the final thing that the book is not an in-depth treatise of anything. We don't cover anything in a lot of detail. In what we try instead is an in-breadth coverage, if you wish, right? Is we try to provide the reader a very wide panoramic of many, many areas that in some cases have entire books on their own. And when we can, we point to those books, because we think if the reader is interested in one particular topic, they should definitely go check out those more in-depth, specific treatments of those areas. What we're trying to do with the book is a first-stop shop, is a welcome to a whole host of topics and fields, and in doing that, you have to inevitably give up on or simplify on other areas. And what we've decided is to try to not cover anything in too much depth, just give the pointers when they're needed, and if people want to explore more, they can on their own. But the book is almost, you can think of it as a welcome mat to a whole host of ideas and areas. And then finally, who is this book for? Who did we think about? What were the, I learned since writing this book, or mostly since talking to publishers, that something they really care about is, who are your personas? Who are the profiles of the people that you're trying to write this book for? And we try to pitch it to at least three profiles, three personas. One is data scientists who are working on spatial problems. These might be people who are working at a startup, at a tech startup, who are working at a government agency, or who are working in research, but heavily working with data. And in particular with data that have a spatial dimension. Now, you might have picked up before that we think there's a lot of data that have a spatial dimension, but we think the book is good for everyone, not only whose data has a spatial dimension, but whose the questions they're trying to answer, the challenges they're trying to solve and fix, have a spatial dimension, or should have a spatial dimension. And for those people, within the book, we'll introduce many of the useful concepts of GI science in a framework that they should be familiar with if they're familiar with data science. We try to phrase many of the aspects of GI science, we try to reframe them or repurpose them in the context of data science. So if you're used to working with Python, working with non-spatial data, this book should feel like an extension that introduces space, that brings an extra column to your data, if you wish, that keeps track of location and keeps track of geography. And the book should not only bring that column, but also teach you a little bit or show you a little bit how you can make the most of that extra column, and how you can use it to make to produce better answers about the questions you're trying to ask. So that's the profile number one. Profile number two is GI scientists who started in the traditional GI science that was taught in the early 2000s, or perhaps even in the 90s, and want to get a refresh on where we think the field is at today, or where we think at least the field is going. So if you got your training in GIS 10, 20 years ago, you probably didn't do a lot of programming, you probably didn't do a lot of statistical learning, you probably didn't combine necessarily a lot of GIS with statistical analysis. You might have been doing both, and in fact this has been at the core of GI science from the very beginning. Spatial analysis was meant to be part of GI science, but it was also in part because of technology or the lack thereof. It was separate fields, right? It was, you would do your GIS in ArcGIS, and then you would complete it, write your files out, and then read them in a statistical system like SPSS or R even at the time, and then work with that as a completely separate entity, separate part of the analysis. A lot of what we think geographic data science is and should be is bringing those two worlds together in the same space, and that is true at a conceptual level, but it's also true at a more technical level. So the book, you can also take it as a handbook on how to do GIS in a modern data science environment that leverages most of the tools that have been developed in the last 10 years, 10, 15 years. And the third persona that we thought about for this book is scientist and social scientist. The three of us, Serge, Levi, and I, are social scientists. So in some ways in some parts that shows in the book, but we think there's a lot that non-social scientists, natural scientists, and engineers could also benefit from, who want to get started in working with spatial data in a modern framework. So a little bit people who don't have a lot of exposure to data science and don't have a lot of exposure to GIS, but want to get started now. We think the book is also a great introduction for that because of what I was saying a second ago, that it doesn't cover anything in depth, but it does cover a wide range of topics, and it's pretty contemporary. So this is a screenshot I took last night of where the book is, and I'm not going to get into a lot of detail beyond saying that there's three main parts in the book. We start with 4 chapters covering what we call the building blocks, a little bit about the conceptual thinking about how do you think about space when you're trying to do data science, and how do you embed space in a way that's meaningful in your data science work. What is the computational environment that you're using? And remember I said a second ago that one of the main differences with traditional GIS is that the technological stack is rather different. So what is that what is that technological stack like, and how do you get it up and running? And then very quick primer on spatial data, and one of the core building blocks that we think for a lot of what will come later, which is spatial weights or geographic graphs as the first one. The second block is what we call spatial data analysis. Here we're bringing in introductory themes that anyone who would have been exposed to spatial analysis or exploratory spatial data analysis will find familiar. But again, we bring them in the context of data science. So things like how to make effective thematic or maps or choropleths. What is the notion of spatial autocorrelation and spatial dependence, and how that works at a local level and at a global level. And then a chapter on points. And then the final block is what we call advanced topics, which take everything we've introduced in the building blocks part and the basic notions that we cover in the second part, and uses them to present slightly more advanced or sophisticated topics. And we cover spatial inequality or methods of spatial inequality in one chapter, clustering and regionalization, so unsupervised learning in another one, spatial regression or supervised learning in the following one, and then we close with a chapter that we call spatial feature engineering, or how can you use space to turn either non-structured data or disparate data sources into consolidated and analysis-ready data sets that you can use in your models. So that's the general content of the book. From a technical point of view, we're also bringing very much in spirit this idea of blending GI science and data science. And I won't spend too much time here, but if you're familiar with Python, I thought you might relate to these slides. So on the one hand, we're bringing the standard industry de facto lingua franca for data science, which is Python, and libraries like Pandas, Xarray, scikit-learn for machine learning, and Matplotlib and Seaborn for visualization. And we're using those as the platform on which to build space into. And to do that, we do it with the modern, what we call the modern GIS stack in Python. Think like GeoPandas, Rasterio for data management, Pysel for all things analytics, OSMNX for working with graphs and spatial graphs, contextually for building, bringing base maps, and many more libraries. We use, there's a bunch of them, but this is just a sample of them. And all of them come together in the same notebooks. I'll talk about that in a second, but all of them come together in the same environment. And the book also has a bonus where every data set that we use inside the book, there's also a page on the book website and on the resource that you can see how those data sets were prepared. A lot of data science is about bringing together disparate data sets, and it's about bringing together real world data. And we felt that if we only used pre-made data sets in the book, it would feel a little fake. But at the same time, we needed pre-made data to make our point more easily and more intuitively inside the book. So the middle ground that we settled on was to come up with data sets that we would prepare, and the preparation for those data sets would also be part of the book. So the book has a section on data that you can see where everything comes from. And then in the final 5 minutes, if I have time, hopefully, I want to talk a little bit about, or I want to wrap up by talking about how we've made this book, and because we think that says a lot about what the book is about, but also what geographic data science is about, and what doing research in the 21st century and doing data work in the 21st century should be like, and hopefully how we can use that to build, going back to the earlier slide, to grow a larger community and a more diverse one that has lower barriers of entry, where it's easier to get up to speed. So I've said it already in passing, the book is written in Python, and this was a deliberate choice. On the one hand, because that was the language that the three of us were most familiar with, but also because we thought there were a lot of really good pedagogical reasons to choose it. On the one hand, Python is a general purpose programming language that is, and this is not me, this is much cleverer computer scientists all agree that it's a language that is well designed to learn programming in general as a concept. So it has good building blocks. It has good underpinnings, but also it's become, we think, the industry standard for data science. So if you look at almost any data science project today in production, things that are running in production, the predictions that serve your movies on Netflix, or the predictions that make Uber or Lyft kind of assign a car to you that can be served cheaply and efficiently, almost all of those systems run in Python. And because of that, there's a huge ecosystem that has grown around the language to support data science. And because there isn't a lot, or there wasn't a lot on how to embed space on these, we thought that was a really good opportunity. There's a bit more in, as I said, in R, which is the other big language in data science. And we thought there was an opportunity there to bring these two communities together through the Python programming language. We're also taking what we call a radically open approach to writing the book. So there's a website where you can follow updates on where we are at the book. And every time we do a talk like this one about the book, it gets posted there. And once we publish it, every activity that has to do with the book will be updated there. But that's basically a blog. So that's open, but it's not radically open. However, the book itself is available as a GitHub repository, everything. So not only the exercises as other books do, the entire content of the book is available online. You can go to GitHub and explore it, or you can go to the website and there's a rendered version there that is ready to to read. And also, we're also writing it in the open, right? It's not that we decided to write the book and then put it out there. Is that from the first day we started writing the book in the open. So you can see our progress, you can see our mistakes, you can see when we add something and it doesn't work and it's wrong and it breaks things. That is all recorded there. And you can also see then when we come back and fix it. Or when people come and tell us that something wasn't working or something wasn't exactly what they expected, whether we could change it. The entire process Yep.
Pardon me. You have still 1 minute left of your presentation.
Yeah, okay. I'm wrapping up. So everything, the entire process, not only the artifact that comes out is in the open. We're also using this idea of code as text. We're using the book as I said, it is not a textbook on programming, is a book that uses programming to teach other ideas about geographic data science. But at the same time, we kind of flip this idea of code as text into text as code. And the whole book itself runs as a software project. It's written in code, it's hosted on GitHub, and it's tested using software engineering practices like any other software project. It's a book that runs anywhere thanks to affiliated technologies. We have a Docker container that then can be deployed on any machine, on any laptop, whether it's a supercomputer, a cloud instance running on Amazon or Microsoft, or on your own laptop. And because we're very much about, as I said, lowering the barriers of entry, we've also made a big effort on trying to make these tools available and runnable by anyone who wants to. So we have, what you see here is a web resource that we created to show you and hopefully get you to install everything you need to run the book. So it's not only about accessing the content of the book, it's about being able to run the book interactively on your own machine. And that's not necessarily trivial, but we've made a huge effort to hopefully make it intuitive. So I'm going to wrap it up here and open for questions. I'll just say that the book is online. As I told you, you can go and try it out. And if you don't have anything installed on your own machine, you can try it on something called Binder that will build a cloud instance for you and let you run it interactively. And if you find something that it's either wrong or is not as good as you would like to, you can try and reach us on GitHub and open a new issue, and we'll try to get to that as soon as possible. And with that, I'll leave it in here and hopefully open for questions. Thank you very much.
All right. Thank you very much, Dr. Dani, for delivering a very interesting topic. And I can't wait to read your distinguished book. And now we have 15 minutes for discussion. If you have any question for participants, please raise your hand and ask your question directly or type the question in the chat box. Is there any question or comment maybe? Okay, while we wait for, okay.
We have one
question. Okay. I will read it for you. It's from Disyacita Awanda. Hi, hello, I'm Awanda. Thank you for your awesome presentation. We agree programming or coding skill is a necessary skill that we need to master nowadays, especially for geoinformation science. But for some of us, programming or coding is frightening thing. Do you have any tips to remove that kind of obstacle when we learn programming skill, especially for geoscience or geoinformation science? Thank you.
Yeah, thank you, Wanda. That's a really, really good question, and one that I wish I had the definitive answer to, and I'm afraid I don't. I do have some thoughts. So I've been teaching at Liverpool a course called Geographic Data Science for 5-6 years, and every year about 100 students take it. Some years is a bit less, and some years a bit more. Most of these students are social scientists, they're geographers, and most of them have never written a line of code. So this is there's a lot of these scary approach, and you can definitely tell the first weeks people are, I don't know if scared, but they're definitely intimidated, I think, by the idea of programming. It's seen as something foreign and distant, and I think there's a lot of levels at which we can operate, or we can try to overcome this first shock moment and this first intimidation. I think, to me, programming is something, and definitely when I try to teach these ideas, I try to introduce it as it's a way of problem solving. If you like puzzles, if you like riddles, if you like detective stories, or if you like solving complicated but fun questions, I think that's exactly what programming is about. And what I try to tell my students is that breaking things is how you learn. So I think a lot of these respect and intimidation comes from the fear of breaking something, that you're going to do something wrong and it's going to break your computer, or you'll never be able to do other things, or you'll have to fix your computer. And I think what I try to emphasize is that breaking things and making mistakes and making errors is not something to be avoided, is something to be cherished. It's something that the more you do, the more you're going to learn, because we all learn by making mistakes. And that's true in other aspects, but it's definitely the case when it comes to programming. So I think that the first hurdle that I try to get the student over is realizing that the way you learn is by making mistakes, and that the more mistakes you make and the more questions you ask, the quicker you learn. And the other one is trying to emphasize this problem solving perspective, that a lot of people think of programming as it's like obscure, really, really hard math that you have to know a lot and you have to learn a lot before you can start understanding anything. And what I try to convey is the idea that it's a much more practical domain. That is, a lot of it is not about understanding obscure concepts. It's about trial and error, at least, well, in the beginning and really at any stage. But that you build an intuition by playing with it, that it's a very hands-on. And once you get those two things, once you get the students on board with those two things, one, that it's okay, and in fact it's encouraged to break things, and two, that this is about problem solving, that it's about solving a puzzle or a riddle, I think students realize that this can be not only useful, but it's also fun. And I think they start spending a lot more time, and as a result, they get a lot better. So I don't have a definitive answer, but that's definitely what I've learned from teaching these to non-programmers. Hopefully that's useful.
All right, it's a very helpful answer, I think, to teach the student with problem-solving case. Okay, we have a second question from Dr. Sanjiwana. Hi, thank you for your presentation. This is really good. I'm currently thinking to migrate from R to Python. However, with the development of other programming language, such as Julia or else, I'm a little bit hesitant. But how do you see Python position in the future, especially for geographic data science?
Yeah, another really, really good question, and one I wish I had the definitive answer for. I can offer you my opinion, at least. And the first thing I should say is that, and this might come as controversial or maybe counterproductive to selling more copies of my book, but is that I don't think everyone or anyone should know every language at an excellent level, right? I don't think everyone should be super proficient in R and super proficient in Python and then super proficient in Julia and whatever else comes next year, right? I think my view is that at least you should be conversant in a few of them. So you should be really good. You should be able to move like a ninja in one of those languages, and that could be R, or that could be Python, or that could be Julia. But then you should also be conversant in the others, because in my experience, there is about 90% of overlap between these languages, particularly between R and Python. You can do almost everything in both languages. The key difference is that well, two differences. One, there's a small set of things that you can only usually do in one language versus another. R, for example, is really good for obscure niche statistical techniques because it's been the lingua franca of statisticians for a long time. And a lot of research has been published in R. At the same time, I think a lot of the cutting edge machine learning, it's either only available or much easier or much more accessible in Python. And that brings me to the second point, that even if you can do certain things in both languages, there are some areas where it's the language or the community around the language in some cases is much more focused on. So picking on R again, I think because it's been the main tool for statisticians for a long time, there are aspects of statistics that even though you can do in Python, I think it's easier to do in R. Things like econometrics, for example, is much more developed in R than in Python. But conversely, there are things that are much more accessible and easier to use in Python. And here, anything to do with machine learning and particularly with deep learning, it's entirely built on Python first. Python is a first class citizen, and R, it's a second class citizen at best. And this is my opinion, it's not a fact. And to your question of whether you should learn Python, I think you should, because I think it's really good to get exposed to different ways of thinking, and because so as an interesting endeavor, I think you should anyways. Depending on what you do, I think it would be much more productive. So if you're doing things with remote sensing, for example, I think to the extent that remote sensing are images, and there's a lot of machinery for working with images because of computer vision, I think you would find Python very, very productive. Same with machine learning. If you're interested in doing machine learning, I think there's a lot more accessible in Python than in R. And also, if you're interested in working with things at scale, and this brings me to the third part of my answer on how do I see Python evolving in the next few years. Because so much of what the current tech world is doing it in Python, there's an entire ecosystem built to take this analysis and run them at scale. So not being able only to train an algorithm on your laptop, but being able to train it for all of the data that Twitter has, or all of the interaction data that Netflix has collected from their users. And that's non-trivial, but that's already developed in Python, and I'm not sure that it's as developed in R or Julia. So if you want to do things at scale, I think it's also very much of interest to at least get some exposure to Python. In terms of what it'll be in the next coming years, I think because so much of the current technological stack is already built in Python, there's a lot of inertia. And you definitely see this in R. It happened in R because it started in statistics 20, 30 years ago. It's still very prevalent in statistics. Because Python was the language of choice for much of what we now call data science, I think it'll still be around for quite a while, and it'll still receive updates, and it'll still be, I think, the state of the art. At some point, probably something like Julia or whatever comes afterwards will start developing, but Julia has been around almost for 10 years now, and it's still, its adoption is not super wide. It's growing, and I think it's healthy, but it's not quite there yet. So whatever starts next will have to start from scratch, and it's not clear to me that there's an obvious candidate just yet. So you might have to switch then later in your career, but it might not be for the next decade or two.
All right. So I remember about your slide earlier that 1 + 1 is more than 2. I think that's what happened with Python and R, I think.
Mm-hmm.
Okay. There are still some questions in the chat box, but unfortunately, our time for this plenary session is up. If you wish, Dr. Dani, you can answer the question in the chat box, and we must move to next session.
Okay.
And
thank you very much, and thanks very much for all the questions.
Okay, I'm afraid I must.
I'm gonna stop sharing.
Okay.
I must screen.
conclude this session. As we all know that our world has transformed into a digital era. And in this new era, some say that data is the new oil. The emergence of the Internet of Things, among other things, has influenced the concept of big data. However, data is not very valuable unless we can harvest information, build knowledge, and achieve wisdom. This is the time where we as geographers must adapt to the disciplines of geographic data science to turn data into actionable knowledge from the perspective of geography. Thank you once again, Dr. Dani, for your nice presentation. Allow me to close this session, and for all participants, you are welcome to attend the next session, which is the parallel session 3, 4, and 5. Stay safe and healthy. I'm looking forward to see you all in person. I hope you enjoy the symposium. Wassalamualaikum warahmatullahi wabarakatuh.
And just one question.